Hey, welcome back. This lesson is the second part to the mole concept, where we realized that to get between the atomic level and the bulk level, there has to be some relationship between how many particles there are and how much mass that has. And the relationship is that there are 6.02 times 10 to the 23rd particles that has a certain amount of mass, and we can't quantify the amount because whatever I have, they all have different amounts. Like a brick weighs differently than a feather, than an egg, than a jelly donut. Like everything has a different mass, so you can't put a fixed number to how much mass it has. But what we can put as a fixed number, again, is how many particles are in the sample and what the bunch of those atoms is called, and it's referred to as a mole. So when you think about ordering bagels, you can go to the store and say, I'd like 3 dozen bagels, or you could just say you'd like 36 bagels. When the quantities are that small and you're working with tangible items that you can count, you don't necessarily have to do it by the bunches. You can certainly do it by the individual items. But because the atoms are so small, you can't talk about it in terms of how many atoms there are because the number's so big. So instead, what the chemists focus on is how many bunches are in the sample, because we know that each bunch has 6.02 times 10 to the 23rd atoms in it. And the bunch is called a mole. So if I had 3 moles of sulfur in this jar, there would be 3 times 6.02 times 10 to the 23rd atoms of sulfur in the jar. So that gets us to talking about measurement. And the focus of this lesson now is, yes, to do a little bit of the math associated with the conversions between how many particles, how many grams, and how many bunches or how many moles, but also to talk about something called significant figures. Let me talk it out first, and then we'll write it down. When I look at the measurement, 41 gumballs, I'm able to literally count that there are 41 gumballs in this jar. This has what's referred to as an infinite number of significant figures. Oh, excuse me, forgot to transfer to the pencil. Infinite number of significant figures. When I look at the measurement or quantity of 37,100 grains of rice, because I didn't count every single grain of rice, who has the time, right? But instead, I counted out 100 grains of rice and then figured out how many bunches of 100 were in the sample. That means that this measurement has 3 significant figures in its measurement. How did I know that? Well, before I reveal that, let's define what significant figures are. Significant figures. Significant figures are all known values plus a guess.